Unraveling the Secrets of Exoplanet K2-18b. The quest to find habitable Earth-like exoplanets is fraught with significant observational hurdles, primarily due to their diminutive size and the faintness of their signals. One promising avenue in this search involves M-dwarf stars, which provide an excellent opportunity to detect and analyze smaller planets, particularly sub-Neptunes, which are among the most prevalent types of exoplanets discovered to date. A notable example is K2-18b, a temperate sub-Neptune located within the habitable zone of an M-dwarf star. Observations from both the Hubble Space Telescope, HST, and the James Webb Space Telescope, JWST, have unveiled that this planet possesses an atmosphere rich in hydrogen, along with detectable levels of methane, CH4, and potentially carbon dioxide, CO2. However, the interpretations of these findings are not straightforward, as they underscore the significance of non-equilibrium chemistry. This aspect is crucial for accurately determining various atmospheric parameters, including metallicity, the carbon-to-oxygen C2 ratio, and a rate of vertical mixing, KZZ. In this study, we delve into the parameter space concerning metallicity, CO2 ratio, and KZZ for K2-18b, utilizing the non-equilibrium chemistry model known as FRICKLE, alongside data from JWST. By generating spectra from a three-dimensional grid of models, we compared these with observational data to refine our understanding of the planet's atmospheric characteristics. To capture the primary chemical trends, we employed a fixed pressure temperature profile while also acknowledging the inherent uncertainties in our approach. Our best-fitting model suggests a high metallicity of 266 degrees plus 291 minus 104 at a 2 sigma confidence level, alongside a high CO2 ratio exceeding 2.1 at the same confidence level. Methane is robustly detected with a log 10 CH4 value of negative 0.3 plus 0.1 minus 1.7 at a pressure of 1 megabar, although the presence of CO2 remains uncertain due to noise in the spectral data. Interestingly, KZZ does not have Pobania significantly influence the fit, leaving it unconstrained. Our findings indicate that non-equilibrium models significantly outperformed flat spectra, achieving a confidence level greater than 4 sigma, thereby confirming the presence of atmospheric features. While minor species such as water, H2O, and ammonia, NH3, may exist, they are likely obscured by more dominant absorbers in the atmosphere. This study emphasizes the limitations of retrieval methods that assume constant abundances across the atmosphere. Here, the elevated CO2 ratio in K2-18b's atmosphere hints at the potential for aerosol formation, yet more precise data is necessary to draw firmer conclusions. Future observations using JWST's NIRSPE Gliese profiles to incredible even more, and the extremely large telescope's Andes instrument will be pivotal in further investigating the planet's habitability and refining our atmospheric models. Authors A. Likaziri, O. Sohir, Ovino, and Carrasco. Subjects Earth and Planetary Astrophysics. AstroPH. CITES RX 2507.14983. AstroPH or RXF 2507.14983 V1, AstroPH for this version, https://doi.org version 210.4855, AstroPH.2507.14983. This research opens up exciting discussions about the complexities of exoplanet atmospheres. What are your thoughts on the implications of non-equilibrium chemistry in understanding these distant worlds? Do you believe that the current models are sufficient, or is there more to uncover? Share your opinions in the comments. Alien life discovery. Strongest ever signs of extraterrestrial life on planet K2-18b. Could we be on the brink of discovering alien life? Recent findings suggest that a distant planet, located over 100 light years from Earth, might be bustling with extraterrestrial organisms. This revelation comes from what scientists are calling the most compelling evidence yet of life beyond our planet. On July 18, 2025, Professor Niku Madhusudan from the Institute of Astronomy at Cambridge University announced that the oceanic planet K2-18b, approximately 120 light years away, has exhibited signs that could indicate the presence of life. Utilizing NASA's Advanced James Webb Space Telescope, JWST, Professor Madhusudan has made groundbreaking observations that have sparked excitement in the scientific community. In an interview with the BBC, he stated, "This is the strongest evidence yet there is possibly life out there. I can realistically say that we can confirm this signal within 1 to 2 years. This statement not only highlights the significance of the discovery, but also sets the stage for future explorations. The atmosphere of K2-18b is believed to contain vital molecules linked to life, specifically dimethyl sulfide and dimethyl disulfide. These compounds are similar to those produced by marine phytoplankton and bacteria on Earth, suggesting a potential biological process at work. During a single observation period, Professor Madhusudan noted that the levels of these gases were thousands of times higher than what we have on Earth. He elaborated, "If the association with life is real, then this planet will be teeming with life. If we confirm that there is life on K2-18b, it should basically confirm that life is very common in the galaxy." Looking ahead, he speculated that in decades to come, we might reflect on this moment as a pivotal point in our understanding of the universe. This could be the tipping point, where suddenly the fundamental question of whether we're alone in the universe is one we're capable of answering, he remarked. The findings, which have been published in the Astrophysical Journal letters, delve deeper into the implications of these discoveries. Professor Madhusudan emphasized that his observations align with previous theoretical predictions regarding Hycean worlds, which are thought to support life. He stated, earlier theoretical work had predicted that high levels of sulfur-based gases, like DMS and DMDS, are possible on Hycean worlds, and now we've observed it, in line with what was predicted. Given everything we know about this planet, a Hycean world with an ocean that is teeming with life is the scenario that best fits the data we have. The signal came through strong and clear. Adding to the excitement, co-author Mons Holmberg from the Space Telescope Science Institute in Baltimore expressed his astonishment at the consistency of the results, saying, "It was an incredible realization. See, the results emerge and remain consistent throughout the extensive independent analyses and robustness tests." But here's where it gets controversial. Could this discovery challenge our understanding of life in the universe? What do you think? Are we truly on the verge of confirming extraterrestrial life? Or is this just an overinterpretation of data? Share your thoughts in the comments below.